So, let's continue the discussion on this free body diagram. Free body diagram. I hope you have watched the first part of this free body diagram because today we are going to solve the problem in which the mass is kept in the inclined plane. So I request you all to first see that video if you haven't seen it, so that you can understand this easily. So first of all, let me make it inclined plane. Okay, so like this. So it is inclined. Consider this is consider this to be inclined by an angle of theta. Angle of theta. Now we will consider a mass which is kept in this inclined plane. So when say mass is m. Okay. Now first of all, our job is to draw a free body diagram. So then you know one thing, there will be a force in downwards direction, that is your gravitational force. Gravitational force. There will be a force which will be perpendicular to the surface. We call it as normal force. Okay, normal force, and this is equals to your mg. Okay, so now one thing you need to understand is this. So to solve this kind of problem, we have to make our xy axis in this way. X-axis just in a similar manner as our inclined plane. Our inclined plane, this plane is going to act like an x-axis. Okay, so this plane is basically going to act like an x-axis. So and perpendicular that to that plane will have our y-axis, okay, like this. So this is our y-axis, this is our x-axis. Our mass that which we have considered is resting in this on this inclined plane like this. Okay, so what we have considered, we have considered a force which is always going to act downwards, that is your gravitational force mg. Gravitational force mg, in this case the normal force will be in the direction of y-axis itself because it is perpendicular to the surface. Okay, this in y-axis you will get your normal force, and I say this angle out here will be equal to theta, the angle the same as this theta. Okay, so this you have to understand. So let me first resolve the components of this mg, and then you will understand what I mean to say. Okay, so mg will have one of its component here. Okay, so here, okay, and the other component mg is going to have in this direction. It's going to have in this direction, and okay, so and I am saying this angle will be equal to your theta. So now let's understand why this is possible. Okay, so first of all, you look here, this angle out here will be your 90. Okay, so the sum of the angle of the triangle is sum of the angle of a triangle is 180. So therefore, if I add theta plus 90 plus, say I don't know what this angle is, so then I have to get 180. So which makes theta plus 90 plus x, which we want to find, is how much? 180. Is the sum of the angle of a triangle. I am looking what x is, so 180, I'm taking this to the other side, it will become minus 90 and minus theta. Okay, so basically 180 minus 90 is here 90 minus theta. So what have we got? This x out here is how much? 90 minus theta. Okay, so this is the case. Okay, so now you see I will make extension out here, extension out here. So this is, so now you also know this entire angle out here is also 90. Okay, and then um, we have seen this going downside, which is your mg. This angle we have got to be your 90 plus theta. Okay, so now if I want this angle, so then if I add this angle and this x, I have to get this entire angle 90. So that means 90 minus theta plus x is going to give me 90. So if I find what x is, so then x will be your 90 minus 90 plus theta. So therefore x will be your theta. Means this 90 and 90 are going to get cancelled. So this x out here will be equal to theta. So that is why we can write this angle out here to be theta. Okay. So okay, so now let's remove this part. Remove this part. Also here we have our mg which is acting downwards. Okay, so and then we have just found that this angle out here will be theta. Okay, so with that respect, what we can do, we can consider the side, the component which is associated with theta with cos theta. Okay, so resolving the component, this will be your mg cos theta, and perpendicular to the mg cos theta there will be your mg sin theta. Always remember, between these two component will be your mg. Okay, so an mg cos theta and mg sin theta will be making an angle of 90 degree with each other. So if I have to make this one out here, so then you will know this will be your mg cos theta, and in this direction we have your mg sine of theta. Okay, so now this completes our free body diagram. Now we have to write the equation for force. Still we are considering this body to be in the state of equilibrium. Equilibrium. So equilibrium. So therefore, uh, the summation of force in x direction will be 0, because we are considering no motion, no acceleration in x direction, and we also know that summation of forces in y direction will be also 0, because there is no motion along this y direction. Okay, so then from free body diagram, what I can write for fx is, so mg sin theta. So I only see one force, which is this in x direction. This is your mg sin theta, and we know the summation of forces in x direction is 0. So therefore mg sin theta will be equal to 0. Okay, so give it as equation number 1. You have got the equation for the sum of the forces in x direction is 0, and followed by summation of force in y direction. So you see y direction, there is n in upward direction and minus mg cos theta. So n is in this direction and mg cos theta is in opposite direction, so therefore I want negative sign. And the summation of force in y direction is also 0, so that means I can write n minus mg cos theta is 0, and which gives n equals to mg cos theta. So this will be your equation number 2. So now we have got both the equation for the summation of force in x direction and the summation of force in y direction. So this is how we solve this problem. Okay, so now let's do one thing. So we can extend this problem. Okay, so we can extend this problem. Okay, so uh, again we are going to make it little bit different. So I am going to uh, make the inclined plane in this another direction, so that you okay. So now here the mass will be resting like this. Okay, so considering mass m, okay, again the angle of inclination of this inclined plane is theta. Now we have to draw a free body diagram. No matter what, one force will be acting downwards, okay, downwards, and another force will always be perpendicular to the surface. That is your normal force. This is your normal force. This is your mg. The next thing that you have to do is you have to make xy axis, and x-axis will be in the direction of this inclined plane. So okay, so this will be your x-axis, okay, and perpendicular to the x-axis there will be your y-axis. Okay, so let me draw here. This is your y-axis, your y-axis. Our mass is resting somewhere out here. Okay, so mass is m, mass is m, okay, and then it is experiencing a force uh, in downwards direction. So downwards direction, this is mg, and your uh, this force perpendicular to the surface will be exactly in your y-axis. Okay, so this out here will be your normal force. And from previous example we know the angle it will be making with this y-axis will be theta, and we have done it. So let's resolve the component. So here in this direction you will have sorry, so you will have this angle to be at theta, and this will be your mg cos of theta. Okay, and then the next thing that you are going to have is your another component. Okay, another component which will be perpendicular to the mg cos theta. Yes, so in this direction, keeping your mg in between. Okay, so this is your mg sine theta. Okay, so this is your mg sine theta and this is your mg cos theta. So to make it a little different in this one, so what we are going to do is we are going to consider one force. Okay, so we are going to consider one force which is being applied to this system in this direction. Okay, so a force of magnitude F is acting on this direction. So now we also have to consider this force. Okay, and let's say yeah, it is making an angle theta with respect to this horizontal okay, or x-axis. So we know that we are considering this inclined plane to be x-axis, so this angle out here is given to be as your theta. Okay, now we have to resolve the component of this force also. Okay, so that we get the component along the x-axis and the y-axis. So that is simple, we all know it. So the F will have one of its component in this direction, okay, in the x direction, and this angle is always already given to be as theta, and perpendicular to this component there will be another component which will be acting upwards. Okay, and we know the side or the component as associated with theta is given by f cos theta, and which is in opposite to the, not opposite, perpendicular to the f cos theta, it is your f sin theta. So now we have resolved all the components of the forces that is acting on this force. So therefore, and still considering this body to be in the state of equilibrium, okay, so therefore net force acting on this body in your x direction will be 0. That means there is no acceleration in this x direction, neither there is any acceleration in y direction, so it will be 0. Okay, so from free body diagram, from FBD, what we can do, we will write summation of fx. So in x direction I see f cos theta and I see mg sin theta also. So the both of them are in the same direction, mg sin theta. Okay, so this will give you as equation number 1. And then moving on to the y direction. Okay, okay, so we also know that this summation of fx is 0, so therefore we can write f cos theta plus mg sin theta is 0, which gives me f cos theta equals to minus mg sin theta. Okay, so here we have the equation for x direction, and for y direction fy. So from this I can see n and plus f sine theta in the same direction, so both n and f sine theta are same direction, so is positive, and minus mg cos theta, so which is in the negative y direction. Okay, so we know the summation of y is also 0, so which makes n plus of f sine theta minus mg cos theta is your 0. If I take minus mg cos theta to the other side, I will get n plus f sine theta is your mg cos theta. So this will be your equation number 2. So this is how we can solve the problem for the inclined plane when the mass is resting on the inclined plane. And to be clear, there is some force missing out here because we have not yet studied friction. Okay, so later on we will also include friction, which will make this equation more physically understandable. Okay, so because here you see, so f cos theta and mg sin theta are in same direction, so there has to be some motion in this direction, but we are saying the body is at equilibrium, so something must be in this direction which is countering this force, but we are not discussing it right now, so later on we will discuss that. Okay.